Hello friends, Namaste. Welcome to the class number 2 on the block diagram reduction technique. So in the previous class we have just discussed about what is the introduction of the block diagram. What is the meaning of block diagram? It is a pictorial representation of a given system. So that is what the block diagram, and we discussed what the main 5 elements in the block diagram. So in this class, we are going to see what are the different rules are there to reduce the block diagram and to find out the overall transfer function. To find out the overall transfer function, we should know the different rules for the block diagram reduction. So then it will be easy for us to solve the problem and find out the final transfer function of a given system. Okay, so totally there are 11 rules are there. In this class, today we are going to discuss the 5 rules. In the next class, we discuss the remaining rules. Okay, so today we discuss how many rules? We are going to discuss the 5 rules. So in the first rule, what is the first rule? We have the associative law. What is the meaning of associative law means? So while solving the different types of block diagrams, will arise many situations. We are going to arise many situations. The final objective is to find out the transfer function of a given system. Okay. Now, so in that the rule number 1 is the associative law. So let us consider a situation. I have a summing point. This is a summing point 1, and there is another summing point 2. So there are 2 summing points are there. So here I am having an input R1 is a one input, and I am having an R2 as an input with the symbol of plus. Okay, and so from the output of this summing point will be given to the S2, and there is another input to this summing point 2. I am taking that one as an R3, and this is a minus. So what is the output of this? So let me tell you once again. Here what is the input? R1 is the input. There are 2 inputs are there to summing point 1. So what is the output from summing point 1? It will be algebraic summation. R1 here. So if there is no symbol, that means it is a plus. R1 plus. Here also there is a plus. So therefore R1 plus R2. The output of summing point 1 is R1 plus R2. So that will be the input for summing point 2. So there is another input summing point 2, that is R3 with the symbol of minus 3. What I told, it will be algebraic summation. So the output will be R1 plus R2. Next what we have? Minus R3. So this is the output. Okay. So if I interchange, what is the meaning of associative law? I can interchange the summing points. For example, so if I interchange the summing points, so R1 will be the input. So there is no change in the input to the reference input. I am shifting the summing point 2 and summing point 1. I am just interchanging it. So this is the summing point 2. So what is the input for summing point 2? We have minus R3. Next, so we have a summing point 1. So what is the input for the summing point 1 we have? It is a R2. So here it is what? Plus. So plus R2. So what is the output? So R1. So what we have here? This is a summing point 2, and this is a summing point 1. So what is the output from summing point 2? It will be R1 minus R3. So that will be the input for summing point 1. So what is the output from this? So it will be R1 minus R3 plus R2. Okay, R1 minus R3 plus R2. See, so this is the case number 1. Here we have summing point 1 and summing point 2. Summing point 2. What is the output? R1 plus R2 minus R3. To check whether we can interchange the summing points. So that's why I just interchange the summing point with S1 and S2. What is the output? R1 minus R3 plus R2. Now compare both the output. Is it same or different? It is same. So that means, so if there is any 2 summing points which are in same line or in series, we can interchange interchange. So that is what the rule number 1 says. We can interchange the summing points. There is one condition is there. What is the condition? There should not be any blocks in between. So this is summing point 1 and summing point 2. So these two are in series. So in between these two summing points, there is nothing is there. No takeoff signal is not there. Block is not there. Nothing is there. So in such cases, we can interchange the summing points. Even though if we interchange the summing points, there will be no change in the output. So this is the rule number. So what is the rule number 2? Blocks are connected in series. Okay, blocks are connected in series. Let us consider a situation. I have a block with a transfer function G1. So there is another block with the transfer function G2. There is another block which is with the transfer function G3. So R is the output, C is the R is the input, C is the output. So these is the blocks. So this is the situation. We have 3 blocks which are in series. So then how we can reduce this one? If the 3 blocks are in series, then this block can be reduced to. So this will be a multiplication of all the transfer function of the blocks. So this can be reduced to G1, G2, G3. So R is the input, C is the output. So if in a problem, if we have this condition, that means there are if the blocks are in series, G1, G2 are in, G3 are in series. In such case, we can multiply all the transfer functions of the block, and this can reduce to this one. Okay, so this is the rule number 2. And there is one star condition is there. What is that? So you need to check whether any summing points are there or any takeoff points are there. If that is there, we can't able to consider the blocks are in series. To demonstrate that one, I am going to take an example over here. So here is the takeoff point 1. So now, can you tell me? So G1, G2 are in series. Okay, only G1 and G2 are in series. Why? Because nothing is there between the block number 1 and the block number 2. But there is a takeoff point is there between G2 and G3. Okay, there is a takeoff point is there between G2 and G3. Hence, G2 and G3 is not considered to be in series. In such condition, only the blocks G1, G2 are in series, whereas G3 is not in series. In the same way, if there is a summing point is there. So if there is a summing point, this summing point is between G1 and G2. Takeoff point is there between G2 and G3. So now which blocks are in series? So in this case, none of the blocks are in series. So all the blocks has to be reduced. Okay. So none of the blocks in series. When we can say the blocks are in series? If nothing is there. So in between the block there should not be any takeoff signal or should not be any summing points. In such conditions only we can say the blocks are in series. If the blocks are in series, we can multiply the transfer functions of all the blocks and we can reduce to a single block. So this is a rule number what? Okay, so blocks are connected in parallel. So this I am going to demonstrate that one. So R is the input. So I have a block G1 to G2 and G3. So all these signals from these blocks are getting connected to the summing point 1. Okay, so C will be the output. So here it will be a plus. I am just taking an example. So R is the input and C is the output. So here we have different blocks G1, G2 and G3. So now this can be said as these 3 blocks are in parallel. Okay, so how it can be set in the parallel? See these three, the flow of signal is in the same direction. That is very much important. The flow of signal must be in the same direction, and these three can be set that they are connected in a parallel, and all the signals are meeting at one common summing point, and they are meeting at the one common summing point. Then only we can say these three blocks are connected in what? Parallel. So if we find this type of situation in problems, we need to reduce this into a single block. So in the case of when the blocks are connected in series, we need to do the multiplication. So when the blocks are connected in parallel, this is an algebraic, you can reduce by algebraic summation. How it can be reduced? What is the input? R. We need to reduce it to a single block. So we have a G1 with the symbol of what? Minus. So therefore it will be what? Minus G1. So we have G2 with the output of symbol what? Plus. So therefore it will be plus G2. Next we have G3 but with the symbol of minus. So then it will be what? Minus G3. The output is C. Okay, so if we got this situation when the blocks are connected in parallel, so then we can reduce this into a single block by algebraic summation. Okay, so how to identify the blocks are in parallel or not? So only one thing that you have to pay attention is that so the direction of flow of signal must be in same direction, and all the blocks has to be connected at a single summing point. So then only we can say the blocks are connected in parallel. Okay, so this is what the rule number 3. Okay, so the rule number 4 is shifting summing point before the block. So what is the meaning? Means I will consider the situation. So I have one input, R is the input, and I have a block. So with the block of G1, and I have one summing point. Okay, so with the symbol of Y is the given input to the summing point, and what is the output I am going to get? Output is I am going to consider as C. So in this condition, what is there? I have summing point is there over here. So what is the signal? The input signal R is the input signal to the G1. So the output from this block will be R into G1. So that will be the input for the summing point 1. So what will be the output for summing point 1? We have another input of Y. So this output will be R G1 plus Y. So this is the output. So we will be having many situations where we need to shift the summing point 1 before the block. Okay, we may while solving the problems we will get different types of situations. There we have to apply all those things, these rules until to reduce to a single block. The whole given system has to be reduced to a single block. Okay, so if there will be some situation, we need to shift the summing point before the block. Okay, see if I shift the summing point before the block. So this is what shifting the summing point before the block. So then what will be the output? So R. So I am shifting the summing point 1 with the input signal of Y. Okay. So here we have a G1. So C is the output. Okay. So now what is the output of this condition after shifting the summing point 1 over here? So this will be R plus Y. Okay. R plus Y. So that is the output from this summing point 1. So after shifting over here. So then we have a block G1. So therefore it will be into G1. So what happens? So here it will be R G1 plus Y G1. Okay. So when you compare these two, whether the output is same? No. The output is different. So as per the rules, even after shifting the summing point before the block, so we need to make such some modifications, the output must remain same. So that is our objective. So in such case, if you want to transfer the summing point before the block, so then how I can make the output same? So to demonstrate that one, instead of y, I am going to consider signal this one as z. Okay, for the demonstration, consider what is this? This is a z. So what will be the here? It will be, okay. So what I need to do is the output must be same, right? So the output must be same. So that's why I am going to equate these two. I am going to equate these two. I will write it over here. So this can be written as Rg1 plus y is equal to Rg1 plus zg1. So I am equating these two. Okay, I have got this one. So after equating these two, now what is the meaning of this? So Rg1 is going to get cancelled. Okay, so what will happen? Y is equal to zg1. So therefore, what is the value of z? So z will be equal to y by g1. Okay, y by g1. So what is the meaning of that? Means, so what I change the signal to y from to z. So that means, so if there is an r, if I am shifting the summing point before the block, so here to this summing point, okay, to this summing point, instead of direct y, I need to add a reciprocal of this block. So I am jumping this block g1. So I need to add a reciprocal of this block g1 over here. So what is the signal I am going to give? The signal will be given as y itself now. Okay. So this is what? Z is equal to y by g1. If I am shifting the summing point before the block, that means I am jumping the block g1. So therefore to this signal I need to add a block, another block which is reciprocal of that jumping block. So this will be g1. So now you can check the output. Now you can check the output. What will be the output? R. So what we have? Y by g1. So what is the output over here? R plus y by g1. So this will get multiplied with this one. So this will be R plus y by g1 into what? We have g1. So then what will be the output? Rg1 plus y. See, so now we are getting the same output. What is the meaning of this rule? Rule number 4 means shifting the summing point before the block. If you need to shift the summing point before the block, so then what we have to do? We need to add a reciprocal of the jumping block. Reciprocal of the jumping block in the summing point. Okay, so this is what rule number 4. Okay, rule number 5. Shifting summing point after the block. Okay, shifting the summing point after the block. So what is the condition? So let us consider a situation where R is the input and I am having a summing point with Y as the input and I have a block with G1. So what will be the output from this one? So it will be R plus Y into G1. So this is the output from this situation. So what is the rule number 5? Shifting summing point after the blocks. In the previous case it was before the block. Now I am shifting the summing point after the block. So what is the meaning of that? I am shifting the summing point after G1. So then, so I am going to rewrite it over here. So it will be R Y. Sorry. So here first we have to write it block G1. So then I am having a summing point with a signal of Y. So now what is the output from this? It will be, so R is getting multiplied with G1. The output from this will be RG1. So there is a summing point 1, RG1 plus Y. So the output will be RG1 plus Y. See, after shifting the summing point after the block, the output has been changed. Okay, so now we need to add some modification. Even after shifting, the output should remain the same. So that is our objective. To demonstrate that one, instead of Y, I am going to replace this with a Z. Okay, so then what will be this one? So RG1 plus Z. As per this previous rule, same thing we are going to do it over here. So we are going to equate this output with this, because the objective is we need to get the same output. So therefore I am going to equate this one, RG1 plus YG1 is equal to RG1 plus Z. So here RG1 gets cancelled. So therefore Z is equal to what? YG1. So what is the meaning of this? Of this, just rewrite it over here. So if the output must be same, so then R, so this is the G1. So here we have a summing point. So this is what the summing point is being shifted from here to afterwards. So earlier it was a symbol of what? Y. So if the signal should be Y, so here I need to add a block of what? G1, the same block which I am jumping, right? So this will be G1. In the previous case it was reciprocal. When I am shifting the summing point before the block, so then it must be, we need to add a reciprocal of the block. So when we are shifting the summing point after the block, so then we need to add a same block to that summing point signal with the signal of what? Y. So here Y into G1. So that will be the input for this summing point. Y into G1. Here R into G1. So that is R into G1 is the input for this summing point. So what will be the output? So RG1 plus YG1. So this is what the required. So therefore, whenever we are going to shift the summing point after the block, so then we need to add a same block to this summing point signal. Okay, so this is what the rule number 5. Okay, so in this class we are discussed 5 rules. What are the first rule? So the first rule is an associative law. So when the summing points are connected in series, we can interchange the summing points. Then there will be no changes in the output. That is the rule number 1 we discussed. What is the rule number 2 we have discussed? When the blocks are connected in series, in such cases we can reduce that number of block into a single block. How we are going to do it? By multiplying the transfer functions of all the blocks, we can reduce that one into a single block. So that is the rule number 2. What is the rule number 3? The rule number 3 that we discussed is when the blocks are connected in series. When can we say the blocks are connected in series? When the flow of signal must be in same direction and all has to be connected to the last same summing point. So then only we can say the blocks are connected in parallel. In such cases, what we are going to do? So that we can reduce that into a single block by algebraic summation. Okay, so we can reduce that one into a single block. So that is the rule number 3. So next, what is rule number 4? Shifting summing point before the block. So that is the rule number 4 that we have discussed. So in such cases, what we have to do? We need to add a reciprocal of the jumping block, okay, to that summing point signal. So that is the rule number 4. What is the rule number 5? The last rule that we are going to discuss for today's class is shifting summing point after the block. So when we are going to shift the summing point after the block, we need to add a same block. See, I am jumping the block G1. So to this summing point signal, I am adding a same block. Okay. So then the output remains same. Okay. So these are the 5 rules we have discussed today. In the next class, we are going to discuss another 4 rules, and then we are going to solve the different problems in the next class only. Okay. Okay. Thank you. Namaste.